judges, my name is Megan Witt, my partner, Mia Williams, and I did a project on a biomimetic hydrogel heart valve, engineering a novel solution to combat infective endocarditis. I wish I could be with you here today, but unfortunately due to a scheduling conflict, I am at a scholarship competition today, but I still wanted to give my portion of this presentation due to how proud I am of Mia and I's work. To begin, I would like to clarify that this is a continuation project. Last year, I was an independent researcher within the microbiology category. I investigated different types of materials to see if any of them had reduced biofilm growth, which related to infective endocarditis, to see if it could be a viable alternative for the pre-existing artificial heart valves in commercial usage. What I found was that hydrogel and another material could potentially be a better solution to the current existing artificial heart valves due to its decrease in biofilm growth, as well as many of the other properties which I will describe to you today. As previously mentioned, infective endocarditis is a disease that infects many people worldwide, in which biofilm grows on different parts of the heart, and specifically pertaining for this project, develop on artificial heart valves, developing biofilm and becoming very lethal for many patients. Current existing artificial heart valves are made out of bioprosthetic materials or mechanical materials such as a pig heart valve or titanium heart valve. But we wanted to design a heart valve that could be biofilm resistant, as well as flexible and biocompatible, and overall a better solution to the current existing artificial heart valves. Hydrogel itself is a hydrophilic polymer that is flexible and can be molded into multiple different things. You may see hydrogel around you all the time, but may not realize it because it's so common within our world. Originally, we wanted to follow a design outlined by these other researchers, but due to limitations and lack of accessibility, we were unable to do so. So we decided to switch up our original plan, which you may see in our research plan, and switch to using pre-existing hydrogel material. And in this case, we decided to use hydrogel contact lenses. To create our design, we needed to have a design criteria. First, we 3D printed a 3D model of an artificial heart valve, and then we decided to make a mold out of that material with a mold maker, and with that mold, we were able to construct our hydrogel heart valve. With the components of our hydrogel heart valve, we used contact lenses and our original goal in mind, which was to create leaflets and a surrounding border, which you can also see within our design goals, in which we wanted to create functional leaflets that could move upward and downward. Upward allowing blood flow through, and downward preventing blood flow from coming back through, and a hydrogel border similar to the current existing artificial heart valves to allow it to connect with the native tissue. To test our material, our design goals was to also have the material withstand a suture test and a friction test, as well as a blood corrosion test. First, beginning with our blood corrosion test, I calculated a p-value less than 0.05, showing statistical significance. I calculated this value using a binomial probability formula so that I could just get this p-value to demonstrate statistical significance, but also qualitatively, if you look at our samples on our board, you can see absolutely zero blood corrosion on any of the samples. And quantitatively, without any statistical significance, the samples weighed 0.06 grams at the beginning of the test, and they weighed 0.06 grams at the end of the test, showing no blood corrosion whatsoever. On to our friction test, we calculated a coefficient for both the hydrogel and the control. For the control, we decided to use silicone. Due to the difference between these two coefficients, the p-value was less than 0.05 once more, showing statistical significance, and that our control had greater degradation of material compared to our hydrogel sample, showing increased mechanical durability of our material. Thank you so much for listening to my presentation. I'm going to pass the mic over to Mia Williams, and she will finish the rest of this presentation and answer any remaining questions that you may have. And thank you so much for listening once more. Have a great judging day, judges!